Hey guys, welcome back to another video. So in today's video, we're going to discuss this question right here in front of you from the JEE Advanced 2022 Paper 2 Physics section. So let's read the question. An object and a concave mirror of focal length 10 centimeters both move along the principal axis of the mirror with constant speeds. So there's a concave mirror focal length. The object moves with a speed v0 is equal to 15 centimeters per second towards the mirror with respect to the laboratory frame. So that's important. The distance between the object and the mirror at a given moment is denoted by u. When u is equal to 30 centimeters, the speed of the mirror Vm is such that the image is instantaneously at rest with respect to the laboratory frame, and the object forms a real image. What is the magnitude of Vm? Okay, so in this question, there is both an object, which is this, and a mirror, which is this, and they're both moving along the principal axis, which is that, at constant speeds. Okay. Now the object moves with a speed of 15 centimeters per second. So I'm just going to get rid of all of that. And this is equal to 15 centimeters per second towards the mirror with respect to the laboratory frame. So this is if we're doing this experiment in the laboratory, this 15 centimeters per second is with respect to us. Okay. Now the distance between the object and the mirror is denoted by u, as they gave here. And this u, at some point of time, at least the point of time that we're talking about, is u is equal to 30 centimeters. That's the instant that we're talking about. Now, they told us that Vm is in such a way that Vi, let's say that Vi is the velocity or the speed of the the image with respect to the laboratory frame, that's equal to 0. That's what they told us at that instant. And the object also forms a real image. Okay. Now we have to find the magnitude of Vm. Okay, so I'm going to scroll down and let's start solving this. So for a mirror, we know that 1 by u plus 1 over v is equal to 1 over f. Now they told us u, which is here, and they also told us f, which is here. So we just have to plug them in using the sign convention, of course. Now, this is the pole of the mirror right here. Let's use a different color. This is the pole of the mirror. And if we're considering the object to be here, this distance is what we need to find. This is what they gave as 30 centimeters. And if we are using sign convention here, now light travels in this direction, but we are measuring from the pole to the object. So remember, in sign convention, the direction in which the light is going is the positive direction. The opposite direction is negative. So here the light from the object, the light rays are traveling in this direction, but if we're measuring this from the pole, it would be in that direction, which is opposite to it. So, let's erase all this. So hence, u would be negative here. So we get 1 over negative 30 plus 1 over v is equal to 1 over f. Now, f here, they gave us as 10 centimeters. Okay, so this also would be measured from the pole to the focal point, and that would also be a negative value because it's in the opposite direction. So this would be 1 over negative 10. So then we'd get 1 over v is equal to negative 1 over 10 plus 1 over 30. And then we would get 1 over v is equal to negative 3 over 30 plus 1 over 30, which is equal to negative 2 over 30. And so we get v is equal to negative 15 centimeters. Okay, so that's v, which is the distance between the image and the mirror at a given moment. So our given moment is when u is equal to 30, and so at that moment, v is equal to negative 15 centimeters. So it's somewhere here. Okay, so now what we're going to do is we need to find the velocity of the mirror, right? So using the same thing that we have here, I'm going to rewrite that. 1 over u plus 1 over v is equal to 1 over f. Now what I'm going to do here is I'm going to differentiate this. So we're going to differentiate this because, I mean, if we are to consider velocity, we need some sort of portion like this, which represents the change in u or v per unit time. So we need those sort of things here. So that's why I'm going to differentiate this, okay? Let's erase that. Okay, so I'm going to differentiate this. This is u to the power of negative 1. That's what this is. So this differentiation would be negative u to the power of negative 2. So that's negative 1 over u squared. And if we're differentiating this with respect to time, then we would have to put a du by dt next to it. So negative 1 over u squared du by dt, and similarly here, plus negative 1 over v squared dv by dt, which is equal to, we could do this same thing with focal length as well, but focal length does not change per unit time. So since focal length is constant, or in this case f is constant, df by dt is 0, and hence we could just directly put a 0 that side. Now let's, set up, make it easier to work with. So I'm gonna put this the other side, so we get that dv over dt. Okay, so now using this, we're gonna find Vm. One thing I need you to remember here, and it's very, very important when it comes to these sorts of questions, is that this u and v, or this du over dt and dv over dt, is all with respect to the pole of the mirror. All of this is with respect to the mirror, not with respect to the laboratory frame. So if we were to consider du over dt, this is velocity. Actually, what we would be considering is the velocity of the object with respect to the mirror. So this would be VO minus VM. And similarly, dv over dt is the velocity of the image with respect to the mirror. So this would be vi minus vm. So that's one thing that you have to remember here. All of this is with respect to the mirror, not with respect to the laboratory frame. In fact, you have to use relative velocity in this case in order to find the velocity of the mirror. So let's continue. We know that u is 30 centimeters, so 30 square, times V0 minus Vm. I think they gave us V0. V0 is 15. Yeah, we'll just directly replace that. 15 minus Vm, which is equal to 1 over, we got V as negative 15 centimeters, so we can just negative 15 square, and dV over dt. So that's Vi minus Vm. In the question, they gave us that Vi is 0 because it's instantaneously at rest. So we'll just directly substitute that. 0 minus Vm. And yeah, so let's simplify this. So 1 over 900 negative 15 minus Vm. And 1 over 225 is negative Vm. Okay, so actually I took this way harder than it has to be. I'll just simplify this. So we finally get that Vm is 3 centimeters per second. So that's it for this question right here from the JEE Advanced 2022 paper. If you have any doubts, go ahead and put them down below in the comments section. And if you want any other questions to be solved, just put them down in the comments and we'll get to that question. Thank you for watching. See you in the next video.